Hello, everyone! Welcome to a series of tutorials on spasmodic voice. Today, I will show you the second component of spasmodic voice, which is our sky component. It should be said that the two most important components are the scene component and the sky component. The sky component is equivalent to the creation in the default when creating a project. In fact, the sky components in the Book of Mountains and Seas is very, very powerful. In other, including game engines, you need to buy third-party plugins to get such a powerful sky component. Okay, today let's take a look at what functions does our sky component have? First, after entering any scene, we can see the layered component on the left. To see our sky components, and then the sky component. The first major classification is divided into dynamic sky and static sky. If we choose static sky, there is no time of day, which is our day-night cycle system. If we choose dynamic sky, there will be our day-night cycle system. Let's first take a look at the static sky. After we click on the sky, after switching the sky, it may take a little while to load. Okay. Okay, after we click it, we can take a look. First, our static sky can to directly set the sky color. For example, right now, there is no sky at all. Such a picture. We can directly set the sky color. Sometimes we don't actually need any sky. And then we only want a background color. Then we switch to static sky. And then select a color. Well, more often, we need a sky texture map. Like now. This texture map, we divide it into single texture and cube texture. The cube map has been seen by everyone just now, which is 6 images of up, down, left, right, front, and back. Currently, there are 2 modes for single textures. One is our HDR texture, and the other is our panoramic texture. Both modes can be directly pasted in. After pasting it, we can also modify the intensity or overlay our sky color. You can take a look. Normally, we use more of. One is a solid colored sky, and the other is our sky texture. Of course, more is our dynamic sky. After choosing the dynamic sky, we can turn off the clouds here. We can see that the dynamic sky is based on a physical-based atmospheric rendering of the sky. It will have such a there will be a glowing effect on the horizon. So the time of day, as we've talked about in the previous class, is on our scene. Then click this and pull this daytime. We can see the dynamics, the effect of the dynamic sky. Okay, this is the effect at night. This is the effect during the day. And our dynamic sky can be pulled very, very far. You can see that it can be pulled to outer space. And we can also zoom in. You can see. When we drag the dynamic sky to dusk, there will be such an effect of dusk. You can see the effect. Okay, let's take a look at our sun. In the last class, I've already talked about it. The sun here is a small circle. How can we make it look like the sun? We selected the scene. Click on the spotlight. Okay, the sun will look more like a sun. Let's go back to the sky. This is our most basic dynamic sky. There is also a very important point in the dynamic sky. That is, in our dynamic sky, there are some which have high performance requirements. We may turn off the atmospheric scattering under the dynamic sky. If we turn it off, we will lose an atmospheric haze. We zoom out. Let's take a look. This thing feels very clear, right? Sometimes we want it to be more foggy. We need to turn on the air perspective. You can see such an effect inside. The air perspective may not be obvious. Let's use a sacrificial scene. Scene to see the air perspective. It will be very obvious. So what is atmospheric scattering? And what is air perspective? Air perspective is for this kind of, in a scene with specific objects. It is. The superposition of its colors is called air perspective. For this pure sky, it's called atmospheric scattering. For example, for this sacrificial scene. After we deduce it, look, the farther away the mountain is, the more the mountain has a foggy and whitish effect. Suppose we turn off the air perspective. Okay, you can see that the whole picture, very flat. This is why it is called atmospheric perspective. In fact, it is related to our perspective, which means that near objects appear larger. It's corresponding to this perspective. It expresses where is far and where is near through color. Let's turn on the air perspective and take another look. You can clearly feel that it is far away. So for the large scene of sacrifice, it is best to turn on the air perspective. Let's go back to this small scene. Let's take another look. The other settings of the dynamic sky. Let's find the sun. Let's find the sun. Now we can see such a, which we call the lens flare effect, which is also called lens flare. We can turn it off. We dragged it away. Then there will be no such lens effect. If we drag it larger, you can see such a lens effect. Then this lens effect, if your view blocks it, it will be directly blocked. If it's blocked by clouds, it will also be directly blocked. Generally, I recommend that you turn it on because it will significantly enhance the realism of this picture. It simulates the effect of a camera. Okay, after talking about our dynamic sky, the most basic settings, let's first take a look at our global illumination. Global illumination is about the lighting effect in the entire picture. The most important one is, of course, our sunlight. Our sunlight intensity is the first. The lower we set the intensity of sunlight, the whole sun and the whole picture will be dimmed. Generally, I recommend you to directly adjust it to 10. We can also adjust the sunlight very large. For example, here, we can adjust it to be very, very large, or even higher. As mentioned before, if I adjust it to a large value, we can directly adjust the automatic exposure to dim the entire image. By default, when not adjusting the automatic exposure, I recommend you to adjust. Well, the sky is affected by sunlight. That is to say, if the sky is not affected, the intensity of the sky is always 5. That's equivalent to this intensity. You can see that I'm adjusting the sunlight now. The intensity of the sky will not change. If I check this box, the intensity of the sky will change with the sunlight. So this is something I recommend you to turn this on. The color of sunlight is a default color. Notice that at this time of dusk. And then look over here. We will feel that the color of the sunlight is a bit warm. It's not white. Why isn't it white? It's because of the option below called "The sun color is affected by the atmosphere." That is to say, when the white sunlight passes through the atmosphere and is scattered by the atmosphere, it will turn into a slightly red effect. We can turn it off and clearly feel that. The light here has turned white. We can also see the entire picture and the atmosphere. The picture doesn't look very harmonious, so I still recommend you to turn it on. It will be much more harmonious. Okay, besides this, we also have a sun azimuth angle here. Because the sun rises and sets throughout the day, rises and sets like this. But every day, in each different season, its azimuth angle is also different. Let's take a look at its azimuth angle. It moves along the horizontal axis. Sometimes we need to adjust it, especially when we adjust the shadow of the building. We may need to adjust it. Okay, this part below is the hole. The most important effect of sunlight, which is our shadow. the shadow effect. Also, when we adjust the performance. Effect we adjust when we adjust performance. Let's take a look at the shadow effect in the top view. When we drag it, we can see that the shadow is a very good effect. But the shadow effect is the most influential effect in our performance. So we need to talk a little more about it. First, we can use this switch to decide whether to turn on or off the shadows. I won't turn it off here, because if I directly turn it off, the shadow will be turned off directly. Then the first one here is cascaded shadow and ordinary shadow. Our cascaded shadow is through, because sometimes in large scenes, the farther the shadow is, right? The shadow actually occupies very few pixels, but it requires a very large shadow texture. Now in the industry, there are many methods. Among them, cascaded shadow is the most common method. It is equivalent to dividing the entire shadow. It's divided into 3 parts, or even 4 parts. And the farther away, the smaller the texture size it renders. In this way, we can use a relatively small texture to render a very large scene. So cascaded shadows are used in large scenes. The number of cascades also determines the quality of the entire shadow. Of course, the higher you drag it, the higher the quality of the shadow will be. But at the same time, the performance is worse. It will significantly increase draw calls. Let's say there are 1,000 objects in the entire scene. The cascaded shadow level 3. It means it needs to render 3,000 times. If it's level 4, it means it needs to render 4,000 times. So the mirror reflection is very, very performance consuming. For small scenes, we can actually choose normal shadows. As you can see, for ordinary shadows, this kind of picture is also okay. But if it's larger, the shadow quality will obviously not be high. Meanwhile, our shadow resolution is also easy to understand. It means the resolution of the shadow texture. The smaller, the blurrier. We can see here. We push the camera up. We can see that it is very blurry here. If we adjust it to this, we can see the leaves here are all visible. Meanwhile, the intensity of the shadow is also easy to understand. The fainter it is, the smaller the intensity, the lighter it is. Shadow offset and shadow normal offset. I suggest you not to modify it. This is to reduce the moire of self-shadow. What is moire? When I click on this shadow, which is very small, there will be this moire pattern. The self-shadow moirize is very, very strong, so we can adjust it through this. We have another way to reduce moire. That is, we need to make our grounds, such as here. I double-click on it. Let's see which part it is. For example, this grassland. When it comes to the moire wall, Because generally speaking, the ground doesn't need to project any projections. We turn off the generation shadow and the receiving shadow because it doesn't need to generate shadows, right? So when we turn off the generation shadow, there will be no more. Let's observe the entire effect. We can see that the ground will look better. This point, I highly recommend that. That is, for objects on the ground, especially those without any height. Don't turn on and receive shadows both on. Turn off the generated shadows. This will significantly reduce the moire. Such a problem. Okay, and then next, spatial adaptation is also quite important. For example, in this space, it's about 3 square kilometers. Or 4 square kilometers. But suppose I'm in this place now. For example, I put a very large plane here. I put a large plane here. But this plane, I don't need it to have any projection effects. At this time, I need to turn off my space adaptability. Like this. Wait a moment. I can put a C. Let me show you the effect. Ocean. For example, now, the surrounding is all ocean, and I have adjusted the ocean very large. I can adjust it too. 10,000 by 10,000. Suppose it's like this, right? You can see that. I didn't adjust the shadows at all. Why does the quality of the shadow become lower? This is because it needs to. For such a large scene, to adjust the shadow. At this time, I only want a shadow changed. I can turn off the sunlight here to turn off the adaptive. And then I manually decided how big it should be. For example, I might have a 1,240 meters. 1,240 meters. A space of 1,000 square kilometers needs shadow, and not outside. Then I just don't use the adaptive. Because once I enable it, it will take my ocean into consideration. Then the whole picture will. The quality of the shadow will be very low. So this is also very important. Then the next one is shadow refresh rate. When there are many dynamic objects, the refresh rate must be set to 1, which means refreshing every frame. But if it's like my current situation, there are static shadows. I can actually make it refresh every 2 frames. After these 2 refreshes, it has no impact on static scenes. But if there is a dynamic object in your scene, you can see it at a glance. The shadow will have a trailing effect. I'll add a dynamic object here. Let me show you. If there is a dynamic object, what kind of problems this thing would have? For example, I have a car here. I put it here. Okay, and then I let it rotate around the screen. Okay, let's play the animation. You can see that such a shadow will have a distinct trailing effect. Of course, because my current relative frame rate is high. So the trailing effect is not obvious. Let's reduce the refresh rate again. You will see such a trailing effect. For example, if I refresh every 5 frames, you can see it will move a little bit after a while. It will move a little bit. I assume it will lag. Look, when I refresh at 60 frames per second, it will catch up every once in a while. It will catch up every once in a while. It will catch up after a while. Of course, you may ask, what's the use of this? Especially in some relatively static scenes. Refresh at 60 frames per second, which will significantly improve the overall performance. As I said before, for the rendering of shadows, we need to re-render the entire picture. So you can adjust it according to your own situation. If there are many dynamic objects in the scene, it is recommended to set the refresh rate to 1. So you can see from the process just now. When I set it to 2, if you have high quality requirements, or low quality, you can hardly see any problems with the shadows. So sometimes we can also set it to 2, especially in the case of relatively slow performance. Okay, this is the refresh rate of the shadows. And for the external projection of the field of view, let's check it to show you. That is to say, the external projection of the field of view. Optimization solution for shadow rendering. When the entire screen is placed outside, things outside the field of view will not projected into the field of view. However, this thing is problematic for some scenes. It may have problems. That is to say, if something outside my field of view, and it will also be projected into the field of view, then it will not be suitable. So this thing still needs to be considered. If for some, the performance requirements are high, but not so demanding on the visual aspect, you can turn on this. The last building's maximum height. We optimize the quality of shadows. We will optimize the quality of shadows. I won't go into the specific technical details. That is to say, under normal circumstances. For example, if the highest building, if it's 100 meters, set it to 100 meters. If it's 500 meters, set it to 500 meters. Generally speaking, buildings about 100 meters, set it to 100 meters. Otherwise, there will be some shadows, especially in the case of cascading shadows, and the quality will be low. Okay, I'm using the regular shadow now. Cascaded shadow. It has a higher quality. Okay, let me take a look. You can take a look at this. this leaf is very, very high. If I increase the cascade shadow, it will be higher. You can see it very clearly. But the cascade shadow just shows the whole. The rendering of the drawing call will significantly reduce rendering performance, especially in our scene. There are many objects in the scene. I suggest that you can use normal shadows. Okay, that's all for the shadows. Let's switch back to normal shadows so that our overall performance will be better. The second one is ambient light. Let me delete this environment texture first. When do we need ambient light? Because we had an environment texture before, so the whole picture looks like it's integrated. Is well integrated. Now that I've deleted the environment texture, we can see that, especially if we turn off the ambient light to 0. We can see the back is completely dark. Normally, the back of the screen will not be completely black. So we provide two ways too. The entire dark picture. The first one is we often, which is the most commonly used in game engines, is to grab the skylight. This is also the most recommended way. We can see that after grabbing the skylight, the whole picture is very harmonious, especially when we adjust it to evening. What color the whole picture is? The color of the atmosphere. It will be the same color, but in some cases, we will. After all, it is. It will consume more performance. We can also have in a relatively high performance way. I turned it off and then use ambient light to simulate it. For example, I drag an ambient light of about 0.05. You can see the background like this, not particularly dark. Meanwhile, we can make it a little bluer. Because we know that the whole sky is blue after scattering by the atmosphere. In this way, I can directly adjust it. But what's the problem with this? When I dragged it to night, it will also be blue. In reality, for the night scene, it shouldn't be so blue. But if you adjust it properly, it doesn't have a big impact. Everyone can decide according to their own situation, especially for those who have high performance. For those with high performance requirements, we can adjust the ambient light. You can see that the whole night, the environment is a little blue. Okay, let's go back to the day. So I recommend that if the performance is acceptable, we don't need to adjust the ambient lighting or set it to 0.1. Then give a white here. And then we directly just select to grab the skylight. This is the most harmonious way for our entire image. Of course, we can also not grab the skylight. We can see here. We can also directly select an HDR texture. This scene is when we choose static. When choosing static skies, it's a recommended way, is the best way. For dynamic skies, we can directly grab the sky. Of course, sometimes the skylights. I think the whole picture is still a little dark. You can also directly adjust the reflection intensity of skylight, as you can see. But under normal circumstances, the most harmonious way here is to use one. This is our global illumination. Global illumination is to make the whole picture is more harmonious, especially during the day-night transition, the process of switching between day and night. We can see that during the day-night transition, the whole picture will follow. The whole sky is lit. It won't look very dark or very bright. Our night effect will also follow the overall light. Okay, after we finish the entire the sky effect, the global illumination effect, let's take a look at the weather. We default to a global wind speed for the weather. What will the global wind speed only affect? Currently, it only affects the animation of the buildings and the vegetation. Animation. You can see the vegetation moving slightly. When I zoom in, I can see that the vegetation moves very violently in the whole picture. The wind direction also determines the direction of the vegetation. Meanwhile, our global wind speed. If we cancel the cloud, independence wind field, it will also affect the wind speed of the clouds. So you can adjust this thing uniformly. But by default, the clouds have their own wind direction. Okay. In addition to the global wind speed, we also have rain. Let's take a look. When it rains, the global wind speed will also affect. When we lower the wind speed, our raindrops will be more straighter. When we increase the wind speed, the raindrops will be blown by the wind. A very steep angle. The global wind speed also affects our snowfall. Okay, you can see that when the global wind speed is high, the snowflakes fly at a very steep angle. When it's raining or snowing, we also have a very considerate function called snow accumulation size. When we drag the snow accumulation size, the entire screen will automatically accumulate snow. No! This function is for everyone. Don't need to do it in the model. We will automatically to fill the entire screen. Meanwhile, our blood volume. The particles of rain and snow can also be adjusted in size. Of course, the same goes for the effect of rain. We can adjust the entire effect of the water accumulation, the effect of the accumulated water. You can see that in the entire picture. There is a good water accumulation effect. Meanwhile, the amount of rain can also be adjusted. Of course, these in the entire picture can also. We can adjust the entire. That is, the weather can be directly. To bind our real-time weather data. Our official website has tutorials on this. You can check out our guide. How to bind the real-time data to the weather. After looking at our weather, let's look at the night sky next. As the name suggests, we need to switch to night mode. Okay, in the night sky. What can we adjust now? Let's go back to the sky. We can see the first one is the star density, which is defaulted to 0.7. The more we zoom in, the more stars there will be. When we pull it to 1, there will be a starry sky effect. Of course, we can cut it first. Let's switch to our roaming camera first. This picture will be more obvious. We can look up and see the night sky. Okay, when we gradually reduce the number of stars, the stars in the night sky will also decrease. The second is the lunar phase. How to deal with the moon phase? First, we need to see the moon. Let's find the moon. Okay, the moon is here. The moon is here. Where is the moon? Just like the sun, when it first rises, there will be a blood moon effect. It will be completely red, and then as it continues to rise, it will turn blue. We can also set some parameters for the moon. First, the lunar phase, which is the most frequently set, which means the moon has different phases, and the effect of the moon's waxing and waning. It will look different. Meanwhile, we can also make the moon very big. We can make it as big as this. Let's observe the moon phase again. You can see the craters on the surface, combined with the clouds in the sky. There will be a very, very good effect. Okay, this is our moons. The moon's phases and the moon's zoom. Of course, under normal circumstances, we can't shrink it so much. We might give a. When we assume the moon is crescent-shaped, we can give a small moon hanging in the sky. This will give a very, very good feeling. Today, in this class, we will first introduce the first half of the sky settings. I will introduce the second half of the sky settings. The second half of the entire sky setting, which is the effect of our clouds and atmosphere scattering. That's all for today's class.